Hello students, in this session we'll continue with the same chapter, that is media access control under the fourth module. In this, in the earlier session, we already discussed about the random access protocols, right? Okay, that is different types of random access protocols allow for CSMA, CSMA-CD, CSMA-C. All this we have discussed. And in this session, we will discuss the second type, that is controlled access protocol. Under this controlled access protocol, we'll see to those three types there here, that is reservation protocol, polling protocol, and token passing protocols. Okay. Controlled access. In controlled access, the stations consult one another to find which station has the right to send. That is, they have a protocol between each other to send, to decide which has to send and which has to wait. Okay. The station cannot send unless it has been authorized by other stations in the group. Okay. We discuss three popular controlled access methods. One is the reservation, then polling, and one more is the token passing. Now, first we will see what is this reservation protocol. Okay. Reservation access method. In the reservation method, a station needs to make a reservation before sending the data. Okay, for example, if you take the railway reservation, usually what you do when you want to go for a journey, you will reserve the ticket and then you will go, isn't it? You will reserve your seat beforehand and then you will travel. Like that, here each station has to reserve its slot and then it can send in that particular slot. Okay, so each time, say there is a reservation frame preceded by this data frames. Okay, now in the here if I say here you have a reservation frame where there is reservation for station 1, station 3, station 4, and 2 and 5 is not reserved. That means it doesn't want to send the data in this slot. It does not have any data to be sent in this particular slot. Okay, now station 1 will transmit its data. Next station 3 will transmit its data in the slot, and station 4 will transmit. Again you have the reservation frame where which station has reserved slot here. That is station 1 has reserved a slot and rest of the stations have not reserved the slot. So followed by this reservation frame, you have the data frame for station 1. Again it will continue, reservation frame followed by the data frames. This is how the reservation access method works. That is, the station needs to make reservation and then send its data. Next is the second type, that is polling. Okay, this second type, that is polling, this is used when you have a network where you have a primary station followed by the secondary stations. That is a group in which it has a primary station and the rest are the secondary stations, and this primary station is going to control the process. Okay, now see to this diagram here, two figures here, this one and first one, and this is the second one. Okay, see to the first figure here where this primary station, this wants to communicate or it wants to send data to the secondary station B here. Here the secondary stations are station A and station B. At this instance, the primary station wants to send data to the destination is B. Okay, this is the sender and this is the destination. What it will do is, initially it will send a select frame to this destination, that is station B. Okay, once if this destination station B receives a select frame, it will send an acknowledgement saying that I am ready to receive the data, whatever you are sending. Okay, once if an acknowledgement is sent from destination B to the primary station, the primary station will now send the data to the destination, that is station B. See here, the data is sent to station B here. And then next what happens? The B, after receiving the data sent by the primary station, this station B will send an acknowledgement saying I have received the data. It is sending the acknowledgement from the destination to the source saying that it has received the data sent by the source, that is primary station. Okay, this is the case, this diagram shows the case when the primary station wants to send data to its secondary station. What if it is vice versa? That is, what if the station wants to send, that is the secondary station wants to send data to the primary station? What happens? This that is shown, that second case is shown here in this figure, where this B has some data to be sent to primary station A. Okay, in this case, what happens is, the primary station, what it will do is, it will send poll, that is a poll function. It is sending the polling function to the station. That is to each of its station, this primary station will send this poll. Okay, polling function. Polling function is like, it is checking if this particular station, secondary station, has any data to be sent to the primary station. Okay, that's why it is sending the polling function or poll frame. Now here in this figure, station A does not have any data to be sent to primary station. So what it will do is, it will send a NAK, that is a negative acknowledgement back to the primary station. Say that means this station, the secondary station A, doesn't have any data to be sent to the primary station. That's why it is sending a negative acknowledgement frame. Okay. Next, primary station, what it will do? It will send the poll to the next station, that is station B. That is, it is checking whether it has any data to be sent. This is called poll function. Okay. Now what happens? At this point, B has some data to be sent to the primary station. So station B, what it will do? In the secondary station B will send the corresponding data to be sent to the primary station, and then it will wait for the acknowledgement. Station B will wait for the acknowledgement. Okay. Once if this primary station receives the data, it will send an acknowledgement saying that it has, this is a positive acknowledgement. Always when it is ACK, that means it is a positive acknowledgement. NAK means negative acknowledgement. Okay. Now it sends an acknowledgement to the sender saying that I have received the data. This is how polling method works. Hope you understood this polling method. The third method is your token passing. Very interesting method, token passing. In this method, a special packet called a token circulates through the ring. That ring means it is a connected stations. Okay, a ring is formed by connected stations. The possession of the token gives the station the right to access the channel and send its data. Possession means once if a station acquires this token, that is a packet, it means that that particular station now has the right to send its data through the channel and the others has to wait. Understood? That is, it will send its data along with the address, that is the destination address to which it has to send. Okay, the token along with the data will be sent through the channel. Next, when a station has some data to send, it waits until it receives the token from its predecessor. That is, the predecessor is the one which has the token. This particular station who wants to send the data, it will wait until it will get the token from the predecessor and it will send the data to the successor. Understood? To which it is sent is the successor and from which it has received the token is the predecessor. Now, see here, as shown in this diagram, you can see that it has a logical ring and physical topology in token passing access method. This shows the logical ring and physical topology. Okay, physical topology we have already discussed in our first module. Just to revise that and understand this token passing here. These are all logical rings, different types of logical rings. Okay. In this method, the stations, here you have 4 stations. Stations in the network are organized into a logical ring as shown. Each station has a predecessor and a successor. If I say this as an example, here if I say this, if I take station 2, which is the predecessor here, station 1 is the predecessor, and which is the successor, that is station 3. Assume that this is a logical connection. Okay, this is the successor. Now, how the right to access the channel is given using a how it is given using the packet called token, isn't it? Okay, and how this token is passed? There should be someone to control the token, isn't it? That is, there is a concept called token management. That is, token management will decide which station has more priority compared to the other stations and which data has highest priority, and when there is a data to be sent by the highest priority stations, what to do with the low priority stations, whether it has to be whether the token has to be sent to the high priority by the low priority or not. All these decisions are made by the token management, and when this token goes out of the link, what to do, all these are controlled by this token management. Okay, now in the figure shows this figure shows 4 different physical topologies, that is physical ring, dual ring, bus ring and star ring, that can create a logical ring. Now we'll see to the first one, that is the physical ring. Okay. In this case, when a station wants to send the token to its successor, the token cannot be seen by others. So, in this case, along with the token, you need not attach the receiver address here. See, only one link is there, one way. It is moving in one. If one sends a token, obviously it will be received by 2, isn't it? And this 4 and 3 will not see this particular token or the message transferred between these two, this, isn't it? That's why it is saying need not send the this address there. Okay. Therefore, the token need not have the address of the successor, that is the next station. Okay. But the problem here is if one of the link fails, say 2 to 3, this link fails, the whole system will fail here. This full system will fail. There won't be connections, isn't it? If this connection is break, then the whole system will fail. So you have a better approach, that is this dual ring approach. As you can see in the diagram, you have two rings here. This black one ring, and the pink one more ring. This is the original ring. Okay, original connection, black one. Okay. In this case, what happens is that is in this dual ring topology. Here the second link is for emergencies. That is, if a link fails, the other link is used to connect and reverse it. See, for example, this network is working fine and data is transmitted between these 4 stations, 1, 2, 3, 4, as like in this physical ring. Okay. And at some time, this breaks, that is a link from station 2 to 3 breaks. In that case, what happens is this station, in this case, if token was passed till this station 2 and this link has failed, then what happens? The token is sent back through this link. Understood? That is, using the pink link, the token will be sent to station 1 and it will continue this connection here, this pink connection here. That is called temporary connection. Okay. This will continue, this accessing will continue until this original link is fixed back. Okay. Once if it is fixed back, again it will take up this particular ring here. Now, what is the disadvantage of this particular dual ring? In this case, what happens is, see, for each station, it has 2 transmitter ports and 2 receiver ports. See, first station 1, it has 2 receiver ports, isn't it? See this black arrow mark, 1 receiver port and 1 more receiver port here, and 2 transmitter ports, that is here pink one, first this transmitter port and this transmitter port. That is total, it should have 4 ports, whereas here you have only 2 ports, isn't it? This is the disadvantage of this particular dual ring. Okay. Next we will see to this bus ring here. Okay. Bus ring formed using a bus topology. See, here you have a common line, or you can say it is a bus, and 4 stations, station 1, station 2, station 3, and station 4 is connected to this bus. But there is a logical connection, this one. This is the logical connection, or you can say it as the bus ring. Okay. Now, here the stations connected to the bus in this topology, that is bus ring topology, when token is passed from a station, it should include its successor address. That is, it should along with the token, when 2 is passing a token, for example 2 is sending the token to its successor, obviously it will go to the bus first, isn't it, and then to the receiver. That is, if 4 is the receiver, then this destination address has to be present in the token which is sent by this particular station 2. That is, to the successor it should send the destination address. Okay, this is the bus ring. And Fine. Rest as it is. The token, the station which has the token can pass the message through the channel. Okay. Last one is this star ring. This shows the star ring topology. Each of the stations, station 1, station 2, station 3, station 4, each of these stations are connected to the hub here. That is a main station called hub. This is called star topology, isn't it? Now, in this hub which acts as a connector, this connects all the stations, right? So it acts as a connector. It has a wiring inside this particular hub which will connect the stations together. All the stations is connected to this hub together using a wiring which is inside this particular hub here. Okay. Now the advantage of this particular star ring is that it is less prone to the failure. Why? Because see, for example, if station 2 fails, or the link from hub to the station 2 or 2 to the hub fails, in that case what happens is the hub will skip this particular station and it will continue the that is transmission between station 1, 4 and 3, and later it will fix the connection to station 2. Okay, that means if you want to delete a node from this node, means of the station, okay, or host from this particular hub, it is easy, and as well as addition is also easy. Just add to the hub here. That is one of the advantage of this star ring topology. Okay, see, in this case, if I say, if I want to add a new node, what do you have to do? It is difficult, isn't it? You have to connect 2 to that particular new station, and from that new station to 3. You have to break a link and then add in between. You have to stop this channel completely and add. But here, even if it is transmitting, in between you can add the node to the particular hub. That is the greatest advantage compared to all other stations. Okay, easy addition and deletion of the stations. Next, where this is used, it is this star ring topology. It is still used in token ring local area network designed by the IBM company, where till today they are using this particular design. Okay, students, thank you for watching this video. This completes the second method, that is controlled access. In the next session, we will discuss the third method, that is channelization protocols. 3 types of channelization protocols. Now we have completed random access protocol and controlled access protocols, right? That is reservation, polling, and token passing. Next we will continue with this channelization protocol, that is FDMA, frequency division multiple access, time division multiple access, code division multiple access. Thank you, students.